Welcome back to Maths with Mrs. J. I'm now starting a series of videos about factorisation. Factorisation is extremely important in maths, mainly because in the later years of maths, we often want to have an expression factorised. We want to have it as a product so that we can then work out when that expression will be zero. That is in calculus, it's in all sorts of areas of maths that you need to be able to factorise quite easily. Certainly once you hit year 11, you are expected to be able to factorise pretty much any usual expression that you would have met without too much trouble. Now this first slide, I go pretty quickly from very easy up to very hard. You'll notice 6 and 7 have a star next to them. I absolutely would not expect students in year 7 or year 8 to be doing number 6 and 7. But certainly by the time you're in sort of late year 9, early year 10, I think questions 6 and 7 would be very appropriate to be doing. You need to do a lot of practice for your algebra to master these skills. Now, let me first of all just point out the fact that expansion and factorisation are doing the opposite things. I have done a series of videos on expansion, and that's when you use your distributive law. Remember, we did our little those things, and we said that A times B plus C was AB plus AC. So expansion is taking a product and putting it into the form of a sum or difference. Factorisation is going back the other way. We're taking a sum or difference and putting it into the form of a product. Now, normally, mathematically speaking, we prefer things to be factorised where possible. So what you're actually doing here is you're using your distributive law in reverse. So let's have a look at the first example here. What we're aiming to do is get a common factor out the front of our brackets and then work out what our brackets would be to make this work. Have a look at both your terms here. We've got a 5a and we've got a 10. What's the highest common factor? Well, obviously 5 can be taken out. Now, what needs to go in our brackets is whatever we would need to multiply that by to get back where we started. So what do you multiply 5 by to give you 5a? You multiply it by a, of course. What do you multiply 5 by to give you 10? You multiply it by 2. So that's the basic way we work with this. It's like expansion, but in reverse. Now, if you have slightly more complicated expressions like this, I like to look at the number part and then my A part and then my B part separately. Look at your 6 and your 3. What's the highest common factor there? It's 3, isn't it? Look at our A squared and our A. We can take out the lower power, which is A. And we've got a B and a B squared, so we can take out a B. So what are we going to need in our brackets to make this multiply back out and work? Well, to get the 6, we need a 2. And to get to a squared, we need an a. Let's just check that that would work. So we'd get 6a squared b. Yep. To make this one work, we need to multiply by a b. If you start with a negative term, I like to take out a negative because I don't really like having a negative at the start of my brackets. It's not wrong to take out a positive common factor, but I just don't like the look of starting a bracket with a negative. So I'm going to take out a -2 here for my numbers. For the x and the y, you can only take out the lower powers. Now let's see what we're going to need to make this work. We're going to need a 2. To multiply with x to give you x cubed, you're going to need an x squared. To multiply with y to give you a y squared, you're going to need y. Now to go from -2xy to positive 6xy, what would I multiply that by? I'd have to multiply that by -3. So just be careful of that. Remember what I've said many times before. The sign immediately to the left of a term comes with that term as a package deal. So what you've actually got here is you've got negative 2xy times your negative 3, giving you positive 6xy. Okay, let's have a look at these ones. This is a little bit different, isn't it? The good news is that a common factor can in fact be an entire bracketed expression. We've got x times x plus 3 minus 2 times x plus 3. Let's bring that x plus 3 right the way out the front as our common factor. Perfectly legitimate to do that. So what are we going to need in our second lot of brackets? Well, we're going to need to multiply that by an x to get back to this first term and by a minus 2 to get back to there. That, by the way, is one of the main techniques we use when we are factorising quadratics down the way. Here's another one that's a similar kind of idea, but we've got an additional step to start with. When you have 4 terms, it can be very helpful to consider them in pairs. So if we look at the first pair here, we have x squared plus 5x. We can take an x out of those as a common factor. Now, we could take out a positive 7, but then we're going to get minus x minus 5. If we take out a negative 7, what are we going to have in our brackets here? Well, negative 7 times x gives us negative 7x. Negative 7 times positive 5 gives us our negative 35. So we're in luck that we have a bracket that is a common factor. So we can bring that out the front. And our second bracket will need to be that. Now, these challenge questions are not meant to freak you out. They're meant to expand your horizons a little. Let's have a look at this first one. Looking at the number part for starters, well, we can obviously take out a 5 because we've got a 5 and a 10. If we have a look at our bracketed expressions, we've got an x plus 1 squared and we've got an x plus 1 cubed. We can take out the lower power of that, which is x plus 1 squared. Now let's work out what we're going to need to multiply that by to get back where we started. If we want to go from 5x plus 1 squared to 5x plus 1 cubed, I'm going to need to multiply that by x plus 1 to the 1, okay, which is just x plus 1. You technically don't have to put your brackets there, but I'm doing it anyway. To go from 5x plus 1 squared to 10x plus 1 squared, you just need to multiply by 2. Now, because there's nothing multiplying these brackets here, I can actually work out that second bracket quite easily without too much trouble at all. It's x plus 1 plus 2, which is x plus 3. And last one for this video, and this one is quite a challenge, but it is important to be able to do things like this. Look at your number part. So we can take out a 2. Look at our x plus 3 brackets. We've got an x plus 3 to the 4th and an x plus 3 to the 5th. We can take out the lower power of those. Look at our x minus 1 brackets. We can take out x minus 1 squared. Okay, now what are we going to need to multiply that by to get back where we started? Well, the 2 parts, okay. The x plus 3 to the 4th part's okay, but I'd need to multiply it by x minus 1 to the 1 to get this first term correct. To get this here, I'd need to multiply by minus 3. Now, I've already got my x minus 1 squared okay, but I've only got x plus 3 to the 4th and I want x plus 3 to the 5th. So I'm going to need to multiply by x plus 3. Tidying up this bracket here, we need to be careful because we've got an x minus 1 and then we've got minus 3x minus 9. Okay, because we've really got a negative 3 out the front. So we get 2 times x plus 3 to the 4th, x minus 1 squared, and then we're going to get x minus 3x is negative 2x, negative 1 minus 9 is minus 10. I would even be inclined, well, it's still not fully factorised because look at this, there's a -2 that can come out of that. I'd bring that all the way out the front and multiply it by this 2. So we're going to have x plus 3 to the 4th, x minus 1 squared, and x plus 5. That one's probably a double star question, to be honest, but good on you if you followed me there. Do some practice of some hard ones and see how you go.